Hello guys, so in this video I will talk you about LSH, which is locality sensitive hashing. Basically this technique is used to find similar kind of things. It could be documents, it could be anything. So for the sake of simplicity I will take, in place of documents, consider one document as a single sentence. And say if we have 100 documents, that means we will have 100 sentences, and each sentence has say 10 to 20 words. So we want to compare the sentences similarity. So basically when we are talking about the document similarity, we will talk about, in this case, just for the sake of simplicity, we will talk about the sentence similarity. So how do we think, how can we say that two sentences are similar? So basically we know that any sentence is made up of words. So like in this case, if we see the night is dark and the moon is red, this sentence which is shown here, you can see we have multiple words, which is is one word, night is one word, is one word, dark. So these are words, and these words in combination makes one sentence. When we talk of document, it will be multiple sentences in one document, but for the sake of simplicity, let us assume one document corresponds to one sentence. And now we have 100 sentences and we want to see which pairs of sentences are similar. So if we have 100 sentences, the number of pairs which we can make out of 100 sentences will be 100 C2. That means 100 combinations, 100 C2, which you can calculate using combinations. So we are not talking of the permutations, we are just talking about the combinations. So combinations will be 100 C2, which you can calculate. Now let us discuss how we will think over the similarity of the two sentences. So think over it. So here we have one word. The first sentences which we have, the night is dark and the moon is red. Let us break these sentences into smaller chunks of, could be word or could be characters. But let's say first three words we are taking. So the night is, this is one combination. Then night is dark, this is second. Then is dark and, this is third. And similarly you can break the complete sentences into multiple such things. These are called shingles. So the night is, you can say it is a shingle of 3, but here we are taking a word wise, it could be character wise as well. So there are 3 words combination in a sequence, and this makes a shingle. So we have multiple shingles comes out from this one sentence. So each sentence will be having multiple shingles in it, and similarly 100 sentences will have multiple singles. Some will be common shingles in some pairs of sentences, and there will be some shingles which are very particular to any given sentence, which will not be available in the other sentences, right? So more the shingles are there in common between any two sentences, more similar it should be, right? So this is just it is not 100% accurate in that sense, but we can say that the sequence also matters, and shingles which are there, that matters, and what is the length in that shingle. That right now we are taking the 3 word as one shingle. You can take 2 or you can take 5 also, and also you can take first 4 characters like that also. So it depends on how you choose the shingles. In this example, the next example, which is this is a K shingle, use it wisely. This is one sentence. Now if you come up with the shingles which are available in this, and just take the first 4. This underscore, this becomes one shingle, then you start with the second character, his underscore, and likewise you third will be I, s underscore I. So like this you will create number of shingles, and this is a list of shingles which is in this one particular sentence. Similarly, you can find all the shingles which are available in all the 100 sentences, right? Now, when we are talking about the pairs of sentences which are similar, right? So as I said, if we have 100 sentences and you want to find the number of pairs you will compare, that will be 100 C2. But that is very time complex, and it is also space complex, which we will discuss see in a while. But there is a process which you can follow, approximate method, but that approximation works very well, and you can find approximately similar documents, near duplicate, you can say. So first what you do is you take one sentence, you shingle it the way we say. You will shingle all the documents, then you do some min hashing, and then at the last you do locality sensitive hashing, where you take bands, and you have bands and you have rows, and that we will discuss in a while. So first of all, now shingles we have discussed what is shingles. We will now discuss about min hash signatures. Consider this is the input matrix, and x1, s2, s3, s4. These are documents. So or you can say these are sentences, s1, s2, s3, s4. Definitely each of these sentences will have some shingles, and some will be common and some will not be common, and some may be that some shingle might be available only, like G is one shingle which is available in sentence 1 and sentence 3. F shingle is available in sentence 1 and sentence 3, and C shingle is present in sentence 2 and 4. Okay, now what you do is you first see the one where it is present. If there is a 0, that means that is not present here. So A, if you see, A is present in first sentence but not present in second sentence, present in third sentence, not present in fourth sentence. Now if you see and take the first sentence, we get the 1 here, and the index is the index of these shingles is 1 here. We put it 1. Now the second sentence we see, and we see that the first row is 0 but the second row is 1. So that means shingle C is present and its index is 2. So basically we will take the index. Okay, now we have third sentence, and third sentence we have A present in the first position, so again it is 1. In the fourth sentence C is present and it is in the second position. So it is an unpermuted sequence of shingles 1 2 3 4 5 6 7, and we got the signature 1 2 1 2. That means in which positions these shingles are present in all these sentences. Now if we permute these shingles, maybe if you place A at the bottom, D at the up, so if the sentences are similar, right? If we see that D is present in 2 and 4, if D comes at the top, then definitely we will get 1 here in the 2 and 4, but its index is 7. We will use that we will use the index. So D is at the top, we will use, then it will be in the first position, so we will use that index. Similarly, so we are creating multiple permutations of these and basically looking at the positions of the shingles. So if two sentences are similar, that means the positions of the shingles will be similar, and henceforth the min hash signatures will also be similar, right? So this is one min hash signature which is created from one permutation of the shingles. Likewise, you can create thousands of permutations of these shingles, and then you create thousands of signatures, and we will use that signature matrix to calculate the similarity between the sentences. How do we do it? Let us see. We have already discussed this. This is the input matrix. This is first permutation, second permutation, third permutation, right? And we get the signature matrix out of it here. So you can see the 3 is present in one position in the first sentence. In the first sentence, if you see, there is 1 1 0. This is the unpermitted input matrix, and these are the permutations of the shingles. Basically, you need to see which of the shingles are present. So in the initial case, the first shingle was present, second shingle was present, and the third, fourth, fifth, sixth and seventh shingle was present. Now if you create a different permutation of those shingles, different signature will be created here, right? If you will see one by one, you will get to know that how these signatures are coming. Now we will see that what is the Jacquard similarity. So if you see the first sentence 1 1 0 0 0 1 1, and second sentence 0 0 1 1 1 0 0. Here you see there is no similarity. These shingles are not present here, but these shingles are present here. So similarity is almost 0. So here you can see in the 1 and 2 sentence the similarity is 0. In 3 and 4 also similarity is 0. In the first row if you see, similarity is 0. So third and fourth, there is no common shingles present. That is the Jacquard similarity. So now in the case of 1 and 3rd sentence, 1 and 3rd sentence, if you see, first shingle is present in first column and the third sentence. So first shingle is present, second shingle is present in this but not in the third. Third shingle is not present in both, fourth is not present in both, fifth is not present in both. Sixth and seventh is present in both. So how many common shingles are there? 1, 2 and 3. 3 shingles are common out of 1, 2, 3, 4, 5, 6, 7. So 3 over 7. So basically you will get the value of when you calculate how many ones we have, right? So 1, 2, 3 and 4. So basically 3 are common in this 1, 1, 1, 1, 1, 1. So basically 3 are common shingles out of 4 present, 1, 2, 3 and 4. So 3 by 4, that makes it 0.75. Now if you come to 2 and 4, you will see that 1, 1, 1, 1, 1, 1, 3 are common. And how many totals are there? 1, 2, 3, 4, 5, 6, 7. We are calculating this one. So 1, 2, 3 and 4. Out of 1, 2, 3, 4 and 5. Right? So 1, 2, 3, 4, 5. We are looking at 2 and 4. So 1, 2, 3, 4. Out of 4 we have 3 common. So 3 by 4 again, right? So these shingles are present 1, 2, 3, 4. These shingles are present Out of these, 3 are common shingles. So 3 out of 4 shingles. Rest are 0. So that also makes it 0.75. This is the Jacquard similarity here. Now in the second row, if you see that similarity is coming out of the signature matrix, which we have calculated after creating the permutations and creating the min hash signatures. So if you see 1 and 3, so first sentence, and this is third sentence, this is fourth. So first and third we have this 2 and 2 common, and 1 and 1 common. So 2 is common, and 2 divided by 3, that gives 0.67. So this is the similarity which you are calculating on the basis of signature matrix. So you can see that as you grow up in the signature matrix dimensions, bigger signature matrix, these Jacquard similarity will be almost equal to the similarity which we are calculating in the signature matrix. Now let us assume we have these sentences, or we can say S1, S2, S3, S4, or C1, C2, C3, C4. Both are same. Assume we have like this, instead of 4 columns we have around hundred of thousands of columns, and each column has around 100 shingles, or you can say 100 integers, because you will label and code these shingles as integers just to label them. So say assume that each sentence is having 100 shingles in it, and we have 100,000 of columns, or 100,000 of sentences. Assume that we have around 80% of similarity, just to understand how this Jacquard similarity and the similarity from the signature matrix is equivalent approximately. So we will see, if you take 100,000 columns, and if you start comparing each of them pairwise, you will have around 5 billion pairs of signatures to compare, or basically raw matrix, input matrix. And you see that this is very sparse matrix, because shingles which are present, that will be only 1, rest will be 0. So this shingles matrix will be quite huge. So it is quite space extensive, and so it is not optimized in terms of its space, and also the time complexity to calculate that this 5 billion pairs of signatures similarity is also quite huge. To reduce this, this algorithm has come into picture. Now what we will do is, we have 100 integers, and we will these 100 shingles. What we do is we break these 100 shingles. This maybe you can consider this first column. We have, instead of these 7 shingles, we have 100 shingles. Now we are breaking that 100 shingles into 20 bands, and each band is having 5 rows. So say 1 1 is one band, 0 0 0 is one band, 1 1 is one band. So basically we have broken this complete input matrix into 3 bands. 1 1 one band, 0 0 0 is another, and 1 1 is another band. Likewise we are breaking, but now we are uniformly distributing the rows, and assuming that 5 rows per band, and we have 20 bands. Likewise, so we will get 100 integers, right? 100 shingles. So in each band we will have 5 shingles. That is the case. And since we have 20 bands of them, so total will be 100 shingles. Now, since we have assumed the probability of any two sentences being similar is 0.8. So the probability that C1 C2 is similar in any one band, in any the probability, because we in each band we have 5 rows, and the probability in any row, like we see the sentence 1 and sentence 2, 1 and 0, this one, the first row, if you see first sentence and second sentence, the probability of these being similar is 80%. This is the assumption. So in each row the probability is 0.8. So if you take 5 rows, the probability becomes 0.8 into 0.8 into 0.8 into 0.8 into 0.8. So multiply 0.8 5 times, that becomes 0.8 raised to the power 5. This is for one band. So for one band the probability comes out to be 0.38. So the shingles in one band, the probability that these shingles are exactly similar in that sense, the probability is 0.38. The probability not similar in any two bands, how you will calculate? So first we know that in one band the probability is 0.38 of being similar. The probability of not being similar in one band will be 1 minus 328, 1 minus 0.328 in one band. Now since we have 20 such bands, so this probability will be multiplied 20 times. So that will make it raised to the power 20, and the probability comes out to be approximately 3 over 1000. That is quite negligible. What does it mean? So it means that the sentences 1 and 2 are not similar. The chances is 3 over 1000. So false negatives in this case becomes very less. Since we have 80% Jacquard similarity, if we use this LSH, it will most probably it will always gives the positives, and the false negatives will be very less. Now if we have 40% similarity, then the sentences which we are going to compare, that should be treated as negative, not as positive, because the chances of being similar is very less, is less than 50%. So if you calculate similar wise, you get that the probability to be similar in one band is 0.4 raised to the power 5, because in one band we have 5 rows and probability of being equal in one row is 0.4, and in one band we have 5 rows, so it becomes 0.4 raised to the power 5. Now probability similar in at least one band becomes 20 times this value, which is 0.2. So the most of the cases it will say, this algorithm will say that this is not similar, that the two documents which is C1 and C2 are not similar, because 40% similarity, we hope that the LSH algorithm works in such a way that it also says that these are not similar, and it should be the case. But when it is 80% similarity, Jacquard similarity, we should always say that these are similar, that should be positive. That's why in the case of 80% we see that the false negatives are very less. In the 40% case it should be negative. That's why we try to see if it is what is the false positive rate. So the false positive rate is also very low. Now the probability of being two documents being similar comes out to be approximately a step function. So what we are doing is 1 minus s raised to the power r whole power b. So first you see just s. What is s here? So when we were talking about 80% probability, so the s was 0.8. We have 5 rows in one band. So the probability had become 0.8 raised to the power 5, that is power 5. So that is actually s raised to the power r, s raised to the power r. So this value is this one. Now we did the subtraction 1 minus 0.328 just to calculate if they are not similar in 20 bands. In all of the bands they are not similar. That we calculated by calculating 1 minus s raised to the power r. After we calculated in one band, we have 20 such bands. So we are multiplying this probability 1 minus s raised to the power r b times, because we have b bands. So basically we have r rows in one band and we have b bands in total. So in our case r is 5 rows per band and number of bands is 20 and s is 0.8 and why we are doing this 1 minus, because we are trying to see the probability of two documents being similar. So we are, in the case of 80% we try to see false negatives, in the case of 40% we try to see false positive, in the case of 80% or 40% we try to see the actual reality. So in the case of 80% we are not focusing on the false negative, we are trying to see what is the probability of being positive, right? So even in the case of 40%, what is the probability of being positive? So the probability when the 40% will be here, the being positive is very less, and the probability when it is 80% Jacquard similarity, then the probability of being positive is also very high. So this is the t, which is the threshold, which comes out to be 1 over b raised to the power 1 over r. And this threshold, choosing this threshold, if you go above, the probability of sharing the bucket becomes almost equal, and if you go below, the probability is almost zero. That means the documents are not similar here. In this case the documents are similar. So this is the threshold which you can calculate from the b and the r value. In the next video I will try to focus more into practical example. I hope this is clear. If you have any doubts, please do comments below. I will try to resolve. Thank you.